Yeah, good morning, everybody. My name is Suneel Guntur. I'm from University of North Texas, Department of Health Informatics. Today, I'm going to discussing about the assignment paper review paper, Journal of Environmental Management. Uh, in the summary of this paper is application of data mining technique and hydrochemical data for evaluating vulnerability of groundwater in Indo-Gangetic Plain. The purpose of the this research paper is it mainly assesses the groundwater vulnerability in the Indo-Gangetic Plain. It is also used in the hydrochemical data and the data mining techniques, which is used to predict the contamination risks from salinity, nitrate, fluoride, and arsenic contamination. And this model is useful in knowing the caliber of groundwater which support the environmental management and sustainability groundwater planning. Coming to the related literature, this paper builds the prior studies of hydrogeological assessments and also enhances the previous models with the machine learning and the spatial precision. And the earlier works were inaccurate and imprecise in terms of space and cause and effect in the current research through data mining and is also used the data-driven modeling to improve the accuracy and cross-validation. And coming to the next research design or strategy, the other of the research conducted investigation that involved the gathering of 110 groundwater samples in both dry and wet seasons, which is measured hydrochemical indicators by using pH, TDS, nitrate, fluoride, and arsenic contamination. And this is applied decision tree and KNN for vulnerability decision classification, which is all the machine learning techniques. And these are the use it is also used the fourfold cross validation and AUC for performance valuation. And the last one, GS based mapping used for the special visualization of risk zones. And coming to the results, discussions, and the conclusion, decision tree and KNN models had high accuracy rates of prediction, like 0.97 and 0.95 of AUC respectively. And north central and the northeastern Indo-Gangetic regions identified as the most vulnerable regions in this project, and also salinity, nitrate, fluoride, and arsenic were the key indicators of this high vulnerability. And coming to the conclusion, finally, the conclusion of this project is that integrating the hydrochemical data with data mining enhances vulnerability mapping informs sustainable planning. And the contribution comes under the workouts, the unique key and combined approach to groundwater vulnerability that comprises hydrochemical analysis and machine learning, and improved the spatial accuracy of risk area sustainability and also the identification. And it also provided the practical decision support tool for policymakers. It set an example for data driven groundwater management in similar regions. And coming to the section 2, critical analysis. In this critical analysis, the first one is overall assessment. Uh, the overall assessment, it is a strong model for assessing groundwater vulnerability. High AUC values validate the models, predict the strength of the vulnerability, and this model is considered as the replaceable and reliable in other regions. And also the next one, research methodology. The research methodology protocols are rigorous and proper, which includes the seasonal hydrochemical sampling as well as two machine learning algorithms like Decision Tree and KNN, and also employed fourfold cross validation for model generalization, and also used JS for spatial analysis, and which also suggests the improvement via more samples and advanced algorithms like random forest. Nevertheless, the study is well designed. It also reproducibility and the future research. It recommends the testing ensures the algorithm like the random forest, SVN, and the gradient boosting, which is for future work enhance accuracy in classification, and also suggests the integrity socio-economic and land use data, which is more seasonable data collection would improve temporal and model performance. And the final one, new knowledge learned. This paper proves the environmental data can be more useful for applying machine learning. Machine learning enhances environmental data usability. Hydrochemical data combined with machine learning models like Decision Tree and KNN improves the vulnerability assessment, and the JS mapping is valuable in practical environmental applications with both environmental planning and the protection of the people. In my future, I am going to discussing about these questions. I am going to study about these questions. I am going to improve my knowledge in this topic. I would like to suggest these questions. What would the model performance be doing when utilized for more sophisticated and assembled methods such as random forest or gradient boosting rather than the minimalistic decision tree and the KNN models of machine learning? And also the second question, would the integration of other factors like land use, industry, or density of a population increase the precision and reliability of the vulnerability assessment model? And these are the two questions I'm going to discussing in the future, and I'm going to learn about basics of this future. And this is the reference I'm going to take. I'm going to take as a reference. Thank you very much for